promised you that we would do a review for the quiz for next week. So here it is. I've basically just gone through and taken bits and pieces of each lesson that we've done together so far, whether that be in person or at home. And I've included, again, those bits and pieces together here in one document for you, and I'm just going to run through them quickly. So because I want to make the video as short as possible for you, there's going to be some times where I just kind of pause myself, and on your end of things it'll look like I kind of skipped ahead through the problems. Again, that's just to speed up the process for you, because I know you don't want to sit here and listen to me talk for 3 hours. So the first part, we have to identify the variables, coefficients, constants, and the number of terms. So this was, I think, the very first lesson that we did. Remember, variables are things that can be replaced. They are letters or symbols that represent any sort of value that can change. Okay, coefficients are the things that the numbers that those variables are being multiplied by. Constants, they just remain constant. They're numbers on their own. And then the terms, remember I told you as kind of a little cheat code, they're going to be separated by plus signs and minus signs. Okay, so in the first one, our variable is x. A coefficient, we've got a negative in front of there. That's a -1. The constant is the 3 on the end, and there are 2 terms. And the second one, our variable is a. The coefficient is -4. The constant is 13, and once again we have 2 terms. And then lastly, we have variables s and r. The coefficient in front of s is a 7. The coefficient in front of r is a -1. Our constant is 8, and there are 3 terms. Okay, next we are asked to identify each of the following as being a numerical expression, numerical equation, algebraic expression, or algebraic equation. Remember, equations have equal signs, expressions do not. So this first one, 50 times 1 equals 2 times 25. That is an equation because there's an equal sign. There is no variable though, so that is numerical, so that's a numerical equation. Next, again, there's no variable, 31 30-seconds minus 1. There's no variable in there, so it's numerical. There's no equal sign, so it is an expression. (2x minus y) has not 1 but 2 variables, and there is no equal sign, so this is an algebraic expression. And then the last one, 2x minus 10 equals 15. There is a variable and there's an equal sign, so this is an algebraic equation. In the next section, we are going to identify the base and exponent in each power, and then we're going to expand each of them. So for the first one, my base is 7, the exponent is 2, so that is 7 times 7. Remember, the base is the thing, and the exponent tells me how many of that thing there are. The next one's tough. The base is -4, and the exponent is 10. That part's not tough. It's squeezing 10 -4s in here. I apologize for doing this to you. See, I've got 1, 2, 3, 4, 5, 6, 7. Oops. 8, 9, and 10. Alright, the next one, remember in our lesson, I rewrote the one that was like this as 16 times x to the 5th, so that we can see that only the x is being raised to an exponent. So the base is x, exponent is 5. This is 16 times x times x times x times x times x. And then for the last one, the entire thing is in parentheses, so my base is 5n, the exponent is 3, that is 5n, times 5n times 5n. In the next section, we're writing them each in exponential notation. 4 is my base. There's 1, 2, 3, 4, 5, 6 of them. So that's 4 to the 6th. Next, I have two bases. The first one is j. I can write that as j, or you could raise j to the first if you want. And there's two k's, so that's k squared. The next one, we have abc times c times c times c. So there are 1a, 1b, and then 1, 2, 3, 4 c's being multiplied together. So I can write it like that. Or if you wanted to, you could also put parentheses just around the AB, and then make c to the fourth its own thing as well. But I usually just write it the way that I have it there. We've got 1, 2, 3, 4 x's, and 1, 2, 3 y's. So this is x to the fourth, y cubed. Or remember, you could flip the order around. Same thing, and going back to those other ones, you could do c to the fourth, BA, c to the fourth, AB. You could do k squared J. So I could do y cubed, x to the fourth if I wanted to. Order doesn't matter. Remember, we did a lesson on properties. Commutative property says that the order doesn't matter for multiplication. Alright, next I have 3, and then there's 1, 2, 3, 4, 5 f's. So that's 3f to the fifth. And then for this last one, negative 3, negative 3, negative 3. There's an x, there's an x, there's an x, and we got a couple y's. So I'm going to do negative 3 in parentheses to the third. I'm going to do x also to the third, and then I'm going to have y squared. Alright, for each of the following, it asks us to translate the sentences into algebraic expressions. Okay, so the first one, we've got the sum of 8 and a number. Sum means addition, so this is going to be 8 plus x. And the second one is the product of a number and 3, so that's telling me to take x and multiply it times 3. Third one, a number decreased by 10, means we're going to start with that number, and we're going to take away 10, so x minus 10. And then number 4, it's 10 less than a number. Remember that word then, that's one of our keywords. It tells us we need to flip the order. So x has to go first, and then the 10 will go after it. We have x minus 10. So it's actually the same answer as what we had in number 3. Okay, a number decreased by 10 is the same thing as saying 10 less than a number. Okay, the next one, it says the county fair charges an admission of $10 and then charges 75 cents for each ride. Write an expression to represent the total cost after R rides at the fair. So you're paying that $10 admission regardless of how many rides you go on. You go on 0 rides, it's $10. You go on 1,000,000 rides, it's still $10 to get in, okay? What changes is the 75 cents for each ride. That 75 cents is going to get multiplied times the number of rides, which in this case we're calling R. And then that gets added to whatever that admission is. So you're paying $10 no matter what, and then we're going to add to that 75 cents, so 0.75, times however many rides you go on, which is R. Okay, below that we're asked to evaluate. Whenever you see the word evaluate, that means that you're going to find some sort of numerical answer. So this is just asking us to follow our order of operations. Okay, so I'm going to start with this first one. I'm going to do parentheses and take care of the 30 minus 3 first. So I get 3 cubed divided by 9 plus 2 times 27. Okay, and so I've taken care of my parentheses. Next I have to deal with the exponent. 3 to the third power is 3 times 3 times 3, which is 27. So I have 27 divided by 9 plus 2 times 27. Next I want to look at multiplication and division, and we do that in order from left to right. So I first encounter the 27 divided by 9. That gives me 3. Then I encounter the multiplication of 2 times 27, which is 54. Lastly, I have 3 plus 54, which equals 57. This next one is a fraction, so I'm going to deal with the top and the bottom separately. So I'm going to show the work for the top over here, and I'll show the work for the bottom over here. So on the top we have 2 cubed minus 6 times 2. I deal with the exponent first. 2 cubed is 2 times 2 times 2, which is 8. I have 8 minus 6 times 2. Next I deal with the multiplication, which is 12. So I have 8 minus 12, and that gives me negative 4. Over here, I'll take care of the bottom. So we've got 4 squared minus 5 times 3 plus 2. Once again, I'm dealing with the exponent first. 4 squared is 16 minus 5 times 3 plus 2. Next, I'll deal with the multiplication. I get 16 minus 15 plus 2. And then I have addition and subtraction from left to right. So I deal with 16 minus 15 first. That is a 1. Then we take care of our addition, and we have 3. Lastly, I put those two back together. This goes in the top, this goes in the bottom, and we end up with negative 4 over 3, negative 4 thirds. Alright, in my last example in this row, we have the absolute value bars, so we have to take care of those first. Remember, they act almost kind of like parentheses, okay? They're a grouping mechanism, so we have to do whatever's inside of there first. So I need to address this. That means I'm going to start with dealing with that exponent. Okay, so this becomes the absolute value of 75 minus 5 squared is 25. 75 minus 25 is 50, so I have the absolute value of 50. That's being divided by 5. The absolute value of 50 is just 50. And when I divide that by 5, I ultimately end up with an answer of 10. Alright, for these next two, we are given values to plug in for x and t, so I've already done that for you. On the left, negative 3 to the third power, when I evaluate that, I get negative 27. Next, I deal with the multiplication over here. I have I'm just going to treat the 8 as though it's separate from the minus and leave it as negative 27 minus whatever I get over here. So negative 27 minus 8 times negative 3. 8 times negative 3 is negative 24. So this is negative 27 minus negative 24. And really I can think of that as being the same thing as negative 27 plus a positive 24. And that leaves me with negative 3 as an answer. For the other problem, again, it is a fraction, so I have to deal with the top and the bottom separately. So I'll deal with the top over here, and I'll deal with the bottom over here. I have 6 minus 4 in parentheses, and then that's being cubed. So I'll deal with the 6 minus 4, that gives me 2. So I have 2 cubed, and when I evaluate that, I get 8. So the top of the fraction is going to be 8. In the bottom, we've got the absolute value of 3 minus 2 times 6. I deal with the multiplication first. The absolute value of 3 minus 12 gives me the absolute value of negative 9, which equals 9. Once again, we put these back together. This is the bottom of the fraction. This is the top, and my answer is 8/9. On the next page, we have a list of a bunch of different numbers, and we're asked to classify them as being real, rational, irrational, integer, whole numbers, or natural numbers. Okay, so when we did this in our lesson, we were just focused on real, integer, whole, and natural. Now we're adding in rational and irrational into the mix now that we are familiar with those. Okay, so through the magic of television, I'm going to have this all filled out in a matter of seconds, and then I'll kind of go through quickly and explain each one. Okay, 0 is a real number, a rational number, an integer, and a whole number. We did that one in our lesson. Remember, it's the only member of the set of whole numbers that is not a member of the natural numbers. The next one is 3 2/3. That is something that can be expressed as a fraction, where it's an integer over an integer. If we wanted to make it an improper fraction, we could. We would add 9 to the 2 that's in the top, and we'd have 11/3. Because it's a fraction that's an integer over an integer, we can say that that is a rational number. but it itself is not an integer, so we would only say real and rational. Same thing for number 3. It is real, it is rational. Remember, decimals that end, in this case, we have -3.7. There's nothing beyond that 7. That is a rational number. Number 4 is an irrational number, because that is the square root of 3, which just, if you were to type that in a calculator, keeps going on forever, and it does not repeat. So that is an irrational number, but it is still a real number. Number 5 is like the other decimal that we had that terminated, so that makes it rational. And again, these are all real numbers. 6 was a tricky one. The square root of 49 is 7. So 7 is one of the counting numbers. That means it's a natural number. And remember, anything that's a natural number must inherently also be a whole number, which must be an integer, which must be rational, which must be real. Okay, so if you have something as a natural number, it needs to be all of those. Same thing is the case for number 7. We've got 5. 5 is also a natural number, so it fits into all of those. And then the last one, number 8, we have negative square root of 25. The square root of 25 is 5, so if I negate that, I get -5. So that is a real number, it is a rational number, and it is an integer, but it is not a whole or natural number because the whole and natural numbers do not contain any negatives. Okay, so related to that, we are asked what set of numbers would be the best to use for measuring a temperature in degrees Celsius, and why. Okay, so if I think about measuring a temperature in degrees Celsius, especially in our climate, Celsius, when something is at the freezing point in Celsius, it is at 0 degrees. So you could theoretically have a temperature, and again, in our climate, we do see it pretty frequently in the winter, a temperature that is negative on the Celsius scale. So I need to be able to represent it with negative numbers. So if we think about the natural numbers, there are no negatives, okay, and there's no 0. Whole numbers include 0, but does not have any negatives. Integers does include negatives. So we want to use integers, okay, why? We need to be able to show negative values. All right, you need to have negative numbers to use. So we can't use the natural numbers or the whole numbers, we need to use integers. All right, down below it asks us to give an example for each of the following properties. So again, through the magic of television, I'm going to write some in here and just go through them quickly for you. All right, so for the first two, the commutative property of addition, I have 3 plus 5 equals 5 plus 3. The order switches. All right, for commutative property of multiplication, it's the same thing, just with multiplication instead. 7 times 9 equals 9 times 7. So both addition and multiplication are commutative. We can change the order, and it doesn't change our answer. Associative property works very similarly. Associative property, we're talking about grouping things, though. So 1 plus the quantity 2 plus 3 is equal to the quantity 1 plus 2 plus 3. Same thing works with multiplication. I can change the grouping around, change where the parentheses are, and it doesn't change the answer. So the quantity 4 times 5 times 6 is equal to 4 times the quantity 5 times 6. Distributive property of multiplication over addition and subtraction. The first one is over addition. So I have 3 and then in parentheses x plus 2. When I distribute, that means that I need to multiply to both of those terms. Please make sure when you're distributing, you actually distribute to both terms. That's one of the biggest mistakes I see is a lot of people will multiply 3 times x in this case, but then they forget to multiply 3 times 2, so they would give me 3x plus 2, and that's just not correct. So 3 times x is 3x, 3 times 2 is 6, so I have 3x plus 6. In my second example, this one has subtraction, but the idea is still the same. Distribute the 7 to both terms. I have 7 times y, which is 7y. I have 7 times 4, which is 28. We still have the subtraction in between them, so I end up with 7y minus 28. The additive identity is 0. So if I add 0 to any number, I get the same number. The additive inverse is the opposite. Whatever the number was, I take the opposite or the negative of it. So 20 plus negative 20 gives me 0. Multiplicative identity, anything times 1 is itself. And multiplicative inverse, if I multiply anything by its reciprocal, I get 1. So 3 times 1 over 37 in this case is equal to 1. Okay, a problem related to those properties there. It says here, when solving the equation 4 times x plus 2 equals 28, Becca wrote 4x plus 8 equals 28. Which property did she use? So she went from 4 parentheses x plus 2 close parentheses equals 28 to 4x plus 8 equals 28. So the right side of the equation remains the same. So what changed is she went from 4 times the quantity x plus 2 to 4x plus 8. So which property did she use? It was one of the ones that we just talked about. She used the distributive property. She multiplied 4 times x to get 4x, and she multiplied 4 times 2 to get 8. So she got after distributing, she got a expression on the left side of 4x plus 8. Okay, and then the last bit that I have here is simplifying radicals. Again, I'm going to save us some time here and go ahead and do a bunch of these, and then I will explain them. Okay, so the first one, we have the square root of 12. Remember, with each of these, in order to simplify the radical, I'm looking for what is the largest perfect square that the number underneath the radical is divisible by. In this case, it is 4. So I'm going to break that into the square root of 4 times the square root of 3. And the reason that I'm doing that is because 4 is a perfect square. I can take the square root of that and replace it or substitute it with a nice integer value. So in this case, the square root of 4 is 2. So I end up with 2 times the square root of 3, which is 2 square roots of 3. Next to that, we have the square root of 144. 144 is a perfect square. What number times itself gives me 144? The answer is 12. Square root of 8, very similar to the one up above it. I break it into the square root of 4 times the square root of 2 this time. Again, substitute in 2 for the square root of 4, and I end up with 2 square roots of 2. For the square root of 48, I can break that into the square root of 16 times the square root of 3. Replace the square root of 16 with 4, and I end up with 4 times square root of 3, which is 4 square roots of 3. Moving down, we have 3/4 times the square root of 72. I break down the square root of 72 into the square root of 36 times the square root of 2. I can replace the square root of 36 with 6. And then I have to multiply those two numbers out in front, the coefficient times the 6 that I just introduced. So I have 3/4 times 6, which gives me 18/4. That gets multiplied times the square root of 2. And then I can reduce 18/4 down to 9/2. So my final answer is 9/2 square roots of 2. On the right, we have the square root of 0.25. Remember, with fractions, with decimals, it's more about figuring out where the decimal has to go. Okay, it looks similar to the square root of 25. The square root of 25 is 5, so I know I'm probably going to have 5 in my answer, but I need to figure out where the decimal goes. If you put it directly in front of the 5, 0.5 times 0.5 gives me 0.25. So the square root of 0.25 is equal to 0.5, or 1/2. With fractions, remember, I can rewrite the square root of a fraction as the fraction made up of the square roots. So I chose to rewrite this one as the square root of 9 over the square root of 64. Both of those are perfect squares, so I can simplify them down to 3 and 8. So my answer is 3/8. On the right, I rewrote that as the square root of 2 over the square root of 49. I can't do anything with that square root of 2. It's staying as the square root of 2. But the square root of 49 I can reduce down to 7. So my final answer is the square root of 2 over 7. And then finally, the last two. I have the square root of 25 over 4 square roots of 4. The square root of 25, we said previously, is 5. 4 gets multiplied times the square root of 4. Well, the square root of 4 is 2, so I have 4 times 2 in the bottom. And that gives me 8. So my answer is 5/8. And then this last one looked really tricky. I had the square root of 169 times the square root of 169 over 13. 169 is a perfect square. When I take the square root of it, I get 13. So this becomes 13 times 13 over 13. 13 over 13 is 1. So I had 13 times 1, which is 13. That's it for our review. If you have any questions about any of this stuff, feel free to get a hold of me. And make sure that you go through any other videos or assignments that we have to help you prepare for the quiz.